Hopefully you can hear me okay here. Let me just make sure everything's working on my little stream. Uh-oh. Is it working on my stream? Oh, I wouldn't be able to tell because I don't have the sound set right on my computer. I wouldn't be able to tell. Whoa, okay, yeah, there we go. Now it's normal, I think. Okay, one more sound check. Okay, that's regular. Okay, yes, welcome. We got a night of math help ahead of us here. We got homework 2, 1, 2, 2, and 2, 3. It's a 20 question. It's a doozy, but I think most of them aren't super terribly hard. I'll try and go a little quick-ish. All right, then we got let's see, we got 2.4, and then there's going to be a review. I might do it today, maybe tomorrow. I'll probably do it today. I don't know. We'll see. We'll see what the time looks like after I finish the first two. Okay, so here we go. We're getting right into it. 2, 1, 2, 2, 2, 3. Here we go. All right, so first ones, the first three here. I'm gonna. If you're watching this, yes. Oh, first in the chat. I'm going to apologize for these first three because I ain't gonna lie. They're tougher than I wanted them to be. They're not something I'm going to put on a quiz or a test because they're more than I expected. But are they something that you could do and is related to the stuff we learned in class? Of course. Like what we did in class was we needed to write an expression for like a story that was going on. Okay? The issue here is they have a slightly more like complicated thing going on. So first let me scoot this over and bring up paint, as we are going to be painting, of course, with the righty board. Alright, so the problem here says Ivan works at a tutor for $8 an hour and a waiter $14 an hour. This month he worked 109 total hours at his two jobs. Let T represent the hours Ivan worked as a tutor. Write the total dollar amount here in this month. So there's a couple things going on here. First, he works two jobs. He gets $8 an hour at one and $14 at the other. It told me how much he worked total, 109. But it did not tell me how much he worked at any particular job. It just says that T should be the number of hours he worked at tutoring. So here's what I'm going to do. I'm going to go over to my board here, and I'm going to write 8T. The reason why I'm writing... Oops, hold on, I got to fix my pen here. The reason why I'm writing 8T is because he gets $8 an hour as a tutor, so 8T represents that. In addition to that, he gets $14 an hour for each hour he does waitering. But, you know, instead of using W or something like that for waitering, they don't want me to use any other letter. They just want me to use T. So how can I not use T? How can I not use W here for waitering hours, but I somehow have to use T? So this is the part that I was saying is a little confusing. So instead of multiplying 14 by any other letter, we're going to put some parentheses. And inside of it, we're going to put what we know he does. We know he works 109 hours, and he spends some of those hours working at the other place. So we're doing 109 minus T. So bear with me on this one. He does $8 an hour for this many hours. T, we don't know. And then he gets $14 an hour, and he gets $14 an hour for 109 hours minus whatever he had worked at the other place, right? So if like T was 50, we'd do 8 times 50. But over here, we do 109 minus 50, because that would tell you how many other hours he did at the other place. So like that's the idea behind how this setup is. So it's a little janky. I mean, I apologize for these problems. I think they're perfectly fine. They're just a little more difficult than I was anticipating. Now, to get the correct answer, you do need to distribute and combine like terms. So we have 8T plus, well, now we got an issue. We got to do 14 times 109. Okay, 1526. Oops, 1526. Okay, and then we're going to do minus 14T. If you're wondering where that's coming from, that's because 14 times negative T. Okay, we got a little bit of like terms here. So 8 minus 14 is negative 6T. Now here's my deal. You could write negative 6T first plus 1526, or you could write 1526 minus 6T. I guess it really doesn't matter the order you write this in. I'd say this is acceptable enough. Boop. Okay, and that was terrible. undo. let's just leave it like that. Okay, so my answer here is he earned 1526 minus 6t. So basically, his pay is $1,526. That's how much he would have earned if he worked all at the $14 an hour place, right? But you have to take off $6 per hour that he works at the other place because he gets $6 less per hour that way. That's not the way you should think about answering the question. I really think you should set it up the way I did here. I think you should set it the way I did here. Oh, good, it's right. Rest in peace, failed circle. Yeah, you're right. Yeah, it's hard. I explained it before. My pen has these little buttons on it, and when you push the button, it does like undos and stuff, and I'm delicately holding it so that I don't touch that. I used to have it set so that button wouldn't do anything if I accidentally pressed it. However, I reinitiated my computer, and it changed all these settings, and now it's not the best. Oh well, whatever. You can complain all you want. You just live with it, right? Okay, so next problem. It says Mai's taking math classes at a college, a community college, Westside, and Pinewood Community College, 2 different colleges. The fees are $98 per credit hour at Pinewood and $115 at Pinewood and $98 at Westside. Oh, okay, sorry, I read that a little poorly. 98 at Westside, 115 at the other one, okay? She's making a total of 18 credit hours. And suppose that W is the west side. Okay, so make sure we set this up correctly here. So she pays $98 per hour, per credit hour at west side, so 98 per west side. And she pays 115 per credit hour at the other place. But just like the last problem, the other place is going to be, well, we don't know how many. We don't want to use a different letter either. We want to say 18 minus W. Because we know she does 18 credit hours, right? So she's doing 18 total minus whatever she did at the other place. So basically same kind of setup as before. Same problem, different numbers. So 98W plus 115 times 18. 2070. That's a year to be alive, isn't it? Or will I? I'd be pretty old at that point. Minus 115W. Okay, we got those like terms again. And it looks like on these problems you're going to very frequently see some kind of number and then some kind of negative variable number. So in this case I get negative 17 when I do 98 minus 115. And the last problem didn't seem to have an issue with me writing the number first, although you could write negative 17 plus 2070. I mean, that's perfectly acceptable. Is there a third one? Oh, there's not a third one. Thank goodness. All right. I hate to see that. Okay. I don't know if this next couple requires like I don't know, the clipboard here. Okay. So the next problem says translate the sentences to an equation. I think this was the level of difficulty I was going for. I don't know what I was thinking when I made those other ones. Oh well, it is what it is. They're good practice. Okay. You never know when you're going to see that on a standardized test, so it's fine that you saw some now, Okay, translate this sentence into an equation. Twice the difference of 3 and a number is 7. So I'm going to, actually, you know what? I changed my mind. I am going to use this thing over here. The reason why is I want to show you this setup. So right here we got the word is, right? That is something you should use as a starting point. If it says is equals, is equal to, why do class fees have to be so expensive? I think 115 per credit hour is like super low. I think maybe 200 a credit hour is kind of normal. If you do ASU, I don't know, 500, 1,000? I don't know. Let's see, I did 15 credit hours a semester and it was like $5,000, so that was 300 a credit hour. So, but that's what you pay to go to university, I guess. All right, anyways, the is represents the equal sign in this one. Now, it's not always going to be the word is. It could be equals or is equal to or etc. I'll put 7 over here because something is 7. Now, here's the thing. You got to figure out how to, I don't know, interpret the left side. Twice the difference of a number and 3. So first of all, let's talk about the difference of a number and 3. So the difference of a number and 3. You'll notice I'm using the letter C because it told me to. That any letter would be fine by me normally, but I got to use what they tell me, okay? And then it says twice. I didn't use twice yet. Now here's the key thing. It's not 2 times c, it's 2 times all of this stuff. So it's twice all of this, which is the difference of a number and 3. It's very specific. You got to go on this one here. So 3 equals 7. Let's just make sure this is correct. I sure hope it is. Okay, good to see. Yeah, so be careful. You might get one that has like a twice or a triple or something like that in there. Hold on, I have to talk to my kid about the room. Oh, never mind. I got wife on duty here.
Leave the nurse out here.
She was playing nurse at the computer. You have to, you know. You got to. Alright, another one. 9 times the sum of a number and 3 equals 6. So let me start with the equals. Equals 6. So I'm going to start by putting equals 6. Okay, then it says 9 times the sum of a number and 3. This is the same as the last one I had. 9 times the sum. So when it says 9 times the sum, we know we have a sum. That's addition. A number and 3. The problem says use y for the number. So I'm going to use y and 3. And then 9 times that sum. So with a 9 on the outside. There you go. 9 y plus 3 equals 6. Okay, now we're switching problem type again. This one just says solve. Now, if you've been in class, I did show you how to solve this on Desmos, but by hand is definitely preferable. You never know when you'll be asked to show your work, wink wink, maybe on a quiz or a test, double wink wink, duh. So here you go. And then I'm going to solve this. So remember, the steps are, is there anything to add or oh, okay, it was nice being Mr. See ya. Okay. Is there anything to add or subtract? Yes, I'll add 15. The problem is the button when I press undoes what I'm currently writing. That's the worst undo ever. 15 plus 15 on both sides. So I get 5u equals 55. I need to divide both sides by 5. Oh, sorry, I'm like getting ahead of myself. I'm about to go say what the answer is. I should write it first over here. U equals 11. Simple, there you go. U equals 11. So these are two-step equations. You just need to like add or subtract something and then probably divide or multiply something. Don't divide by 0, Mr. Chat. Okay, another one. These are all positive numbers. That looks like it's going to be nice and easy. Okay, so here we have this plus 11. That's the first thing we get rid of. So we subtract it on both sides. You get 3v equals 51. Divide by 3 on both sides now. And 51 divided by 3 is 17. So I'm going to put v equals 17. Speed round. There's 4 people here. That's like the most I've ever gotten. Woo! Thanks for watching. I'm happy that somebody's using it, of course. I wish more would, but I'll take what I can get. 4y plus 17 equals 57, minus 17 on both sides. 4y equals 40. Then you divide by 4. So hopefully you're getting the gist of that. You're trying to add or subtract what you can, and then whatever's left you'll need to divide or multiply most likely. I mean, sometimes you don't. Like if this says, mine says 4y, so I ended up dividing by 4, but if it was just y plus 17, I guess that'd be one step. I'm not going to give you guys a one-step equation. We did some of that in class, but I'm probably not going to give you that on a test. That kind of seems a little too trivial, in my opinion. Wait, does he count? Oh, that's definitely, well, I don't know. You're not really a student in my class, maybe. Ha! I never thought of that. Yeah. The best stream on the internet right here. Math help. Alright, here we go. Solve for y. So I want to get rid of 77, so I will subtract it. And 283 minus 77 would be 206. Now before you get all excited and say, wow, that was easy, one-step equation. No. There's a negative in front of that y. And your problems that you'll have that are similar to mine, like my number 8, they're going to have this thing where the variable is negative on purpose because there is a second step that they want to make sure you're careful about doing. So the secret to getting that negative off the y is to divide by -1. Or multiply by -1. I mean, both work. You really should show it Because if you just say, oh, I moved the negative over, that's not really showing what you're doing to make that happen. So when you divide 206 by -1, you get negative 206 equals y. Now, I will say on all these, they don't. The thing doesn't suggest it. Could you check your work? Does 77 minus negative 206 make the right answer? Like, you can check that. 77 minus negative 206. And it makes 283, which is what that said on the left. So, yeah, there you go. Easy to check your answer, too, right? Like, if you're taking your test and you want to be sure you're right, it's as simple as just plugging it back in, right? I'm guessing there's going to be a second one of those. Of course there is. Because I have OCD and I have to make sure there's 2 of everything. Not to mention it's math. Like, practicing a thing a single time really is not enough to warrant possibly learning how well you are at it. You know, I mean, maybe you could get it, but I don't know. Alright, so here we're going to minus 145 on both sides. And you get negative v equals 239 minus 145. 90 something? You know what? I'm going to use a calculator. I'm too lazy to check. 94. Okay, you got it. I failed. I should have done that mental math. Now I feel like a doofus. That's okay. You know, use a calculator. It's better to be right than not right, I would think. Okay, I divided by -1 just like last time, and I got negative 94. If you want to check, does 145 minus negative 94 make 239? I mean, it should. So at this point, you're probably thinking, is the answer always negative? I mean, don't get your hopes up. It could be or could not be. I don't know. The other question is, maybe some of you are thinking, could I have just added v to the right side so it's not negative anymore and I don't have to do this negative step here? Yeah. But instead of minusing 145, you'd be doing a little bit more steps. No, you'd be doing the same amount of steps, just with different things. And I don't know. It's kind of up to you. I think you should just follow this pattern here. It's a good idea. Will you see one of those on a quiz? Yeah. I'm not even going to lie to you. The answer is yeah. Alright, more two-step equations. But the two-step equations here now, unlike the ones I did a little bit earlier, these have more negatives. Like you have negative integers here and there. Possibly negative answers. I don't know if I had negative answers before. So, same as before. Is there anything to add or subtract over here that's near the u? Of course, you got to add 5. You get 3u equals negative 12. You divide by 3. And u equals negative 4. And there you go. Now, at this point, I do want to show you this. Can I copy this? Oh, man, it can't be copied. Darn. Okay, so let me go to Desmos here real quick. So 3u minus 5 equals negative 17. Although you'll notice I did not type u, I typed x. If you go on Desmos and type this in, it'll graph this vertical line right here, right? And if you check where it crosses at the answer. Now, I said that's a way you could do it in class. I encourage you instead to use it to check your work. So, and you could plug the answer back in, see if it works. You could graph it like this, see where it crosses. I mean, that gives you the answer. Like, a worst case scenario, you have no idea what else to do. This gives you an answer. As long as you remember, you just need to graph it using x as the variable. I might as well show you this here while we're at it. If I made y the variable, it would also work, but instead be going horizontally, I guess. But if you type in, u, then it goes, I don't know what to do with that. So make sure you choose a variable correctly. Check. Next problem. Another one of these. Okay, here we go. We got negative 16. They really switched it up on me here. They put the single number on the left side. Ooh. Just be careful. You're not always moving stuff from the left. Like, I think sometimes people get that idea in their head that I have to just move whatever's on the left to the right. I mean, I have been doing that, but in this case, no, don't do that. Add 6. Add 6. You get negative 10 when you combine negative 16 and 6. 5y gets divided by 5, and you get negative 2 equals y. Oops, didn't put a negative. And I put a negative 02, of course. Okay, negative 2. So, light work. Just keep on, doing the steps here. Another one. I put a lot of these. I'm sorry I put so many problems, but I'm not really that sorry on account that A, you have a whole lot of time to do it, and B, you really should make sure you practice these skills. Manipulating equations is super, like, it's not going anywhere. It's super important in math. You're going to be doing it every single year of all of high school, so it's just good practice to keep doing a lot of right now. All right, I want to get x by itself, so I'm going to get rid of this 7. I'm going to add 7. I'm going to get negative 21 equals 3x, and I'll divide by 3, and I'll get negative 7 equals x. You're noticing as I'm doing these possibly that I'm getting a lot of whole numbers. Is a whole number always a well, okay, whole number or integer, I guess. Is an integer like always a guaranteed answer? Absolutely not. You could get a fraction of an answer, or decimal, I guess maybe. Like, it doesn't have to be these, you know, nice numbers I'm getting. I just happen to be getting nice numbers, so it is what it is. Yet another one. Oh, hold up. I broke the stream, guys. There we go. All fixed. I don't know how that clicked on that. That was weird. Alright, anyways, we got 3. Uh-oh. Try that again. 3 plus 2y equals negative 9. I'm going to subtract 3 on both sides. I get 2y equals negative 12. And then I divide by 2. So I think the steps are pretty straightforward. You need to like add or subtract and then multiply or divide on these types of problems, right? There is an issue though. If you struggle with like these operations, like I'm well aware 3 weeks into the year that there are plenty of people that would do negative 9 minus 3 and call it 6. Positive 6, mind you, even. Or negative 6, but both of those are incorrect. So if you are not sure, negative 9 minus 3, literally go on a calculator and just type negative 9 minus 3. There you go. That's all you got to do. Okay, so if you're unsure, please check. Like, better to check and make sure you've got the right number rather than, you know, I mean, I don't want to tell you not to trust your mental math, but if you're not confident enough, then maybe you should try it. And maybe if you are confident enough and you've been getting them wrong, maybe you should try it too. I don't know. Okay, next, we're finally switching up to something different here. Thank goodness. So on these ones you have two options. Option number 1 is you need to distribute the 2 into the parentheses. Or option number 2, which we did do a few problems of in class, is instead of distributing the 2, you could just start by dividing the number on the outside. Now, I would only recommend doing that if the right number is already divisible, like is 14 divisible by 2? Okay, then it's fair game. If this was like a 3 and 14 wasn't divisible by 3, then that would probably be a bad time to start like that. I mean, it still could give you a right answer, but... Okay, so what I'm saying here is I could have distributed that 2. I did not distribute that 2. I instead just said, I'm going to divide both sides first. That gives me 7 on the right, which I'm then going to add 9 to both sides. And that's going to give me 4y equals 16. And I'm going to divide by 4. And 16 divided by 4 gives me 4. Y equals 4. Again, just like the earlier ones, you could graph this on Desmos. You could, I don't know, plug in 4 and see if it works. 4 times 4 is 16. 16 minus 9 is 7. Does 2 times 7 make 14? Sure does. So, I already know I'm right because I plugged it in and checked. Another one. Click the brushes. I have to click the brushes each time. No way around that. Each time I delete, I gotta click brushes. Alright, on this one, I'm gonna treat it like maybe a person who says, okay, I'm gonna distribute. Because I get the feeling that a lot of people, when they see this, are gonna go, I'm just gonna distribute. Okay, that's fine. You're not gonna be wrong. 2 times 2 is 4. 2 times 7 is 14. And then you got 42. The only issue with not doing the division of like this number on the outside 2 first is you get a big number to mess with here, but I mean, it's not too bad. Uh-oh. Sorry, I have to sneeze. I wanted to mute the mic, but I couldn't reach for it in time. Instead, I think I just gave myself some kind of bodily damage by holding that sneeze in. Alright, 42 minus 14 is 28. So I minus the 14 on both sides. I divide by 4 on both sides. X equals 7. And then you can confirm, does 2 times 7, which is 14, plus 7, which is 21, times 2 equal 42? Yes, it sure does. Alright, just cruising along here, man. Well, would you look at that? We got a fraction going on here. So 4x plus 23 over 5. Now, I mentioned this in class, but I'm going to mention it here again. This stuff on the top of this fraction bar is pretty much locked into place. You can't mess with 4, and you can't mess with 23, because this all over 5 stuff is kind of like holding it there. It's an unwritten, literally, rule that there's parentheses around this stuff, and therefore the parentheses have to be, you have to deal with the stuff outside the parentheses here before you can mess with the stuff on the inside. Now that sounds contrary to what you have always heard. You're always like, do parentheses first. But when you're solving equations, you need to do parentheses last. It's like the opposite order. Okay, so the question now is, how do I deal with this 5? Well, it's dividing by 5, so the opposite would be multiplying by 5 on both sides. So these two 5s on my right end cancel out, and 5 times 3 gives me 15. And then I'm left with 4x plus 23. Okay, now I'm going to minus 23 on both sides. Remember, I want to get rid of all the stuff with x. 4 and 23 needs to go. So this gives me negative 8 equals 4x. I divide by 4. 8 divided by 4 gives me, well, negative 8 divided by 4 gives me negative 2. And there you go. So same as some other ones, this one had a different thing. I mean, a lot of the time we've been adding, subtracting, and then dividing. But in this case, we needed to multiply first of all things, and then do some other kind of operations to get it done. I guess there's going to be a second one of those. There sure was. Okay, I just want you to all remember, though, I could have done these on Desmos, but I'm very specific that I want to show you some work, because when it comes to showing your work here and getting some kinds of credit, you really got to make sure you know what to do, okay? Okay, similar, we got this stuff over 4, and again, the top is locked, so we don't mess with it. We multiply by 4. I just want you guys to know every time I write something and then it erases what I'm in the middle of writing, it's because I mushed that button on the pen on accident, and I'm sad. There you go. So I multiplied by 4, and I got negative 20 on the left, and the stuff on the right canceled out. All nice. Now I'll add 20. Oh, whoa. Okay, that's it. I gotta hold it terribly. You'll notice my penmanship gets worse when I hold it this way to avoid this. I get 6 when I add negative 20 plus 26. 3x, divide by 3, divide by 3, 2 equals x. What do we got here? Oh, more of the same. Although it looks like on this one we got all kinds of negatives all over the place. That's cool, I guess. You never know, we might get some negatives. Alright, we got 5x minus 22, negative 3. So same situation, different numbers. We got negative 3 on the bottom. Now you do need to multiply both sides by negative 3. Yeah, hold on. Let me do it like this. Oh, that is so okay, whatever. You know what it is. It's negative 3. So when I can do the left with negative 3, they cancel out. Good, because we don't want to see that gross thing I wrote ever again. 5x minus 22. On the right, you get 18. Be careful. Negative 6 times negative 3 make positive 18. I'm going to add 22 to both sides. You notice that after I do the first step, we're just back at a two-step equation. And then we got 40. I'll divide by 5. And x equals 8. I'm hoping that if you're watching this whole thing... Well, first of all, why are you watching this whole thing? You would think after seeing, like, 6 of the same thing, you're like, alright, I got it, Parsons. I don't know how watching, like, 3 more is going to help me. But maybe it will, I don't know. Alright, what are we at? 19. We're almost done. Now, this one's a bit of a doozy. They got a fraction and decimals going on here. So, I mean, that's okay. I mean, you could get fractions and decimals at the same time. And there's all these negatives. Woohoo. So excited. Alright, so first step is I don't want any of this stuff over here with W. I don't want the dividing by 3, and I don't want the 3.3. Now, unlike the other problems where we were dividing, we undid the division first on those because the whole side was locked away by division. But here the whole side isn't locked away. This 3.3 is okay to move, and we should do that first. So we will do that first. We will add 3.3 to both sides. This will give us W over 3. And on this side, when you combine negative 10.8 and positive 3.3, you get negative 7.5. Okay, now we can multiply by 3 on both sides. So that causes this side to become W. And 7.5 times 3, well, negative, is negative 22.5. Calculator could be your friend there. I'm just going to calculate for myself, I guess. Ooh, look at all those fractions. You gotta have at least one problem where you practice like using fractions. And this is all fractions. I might actually have to dip into the calculator on this one. The reason why is because it'll save me time. And I'll show you as often as I can how it can save you time. So first you need to identify what needs to move. We're going to solve for u, right? So we don't want the negative 1/3 over here. And we don't want the negative 2/5. So I need to add or subtract what I can first. And 2/5 is addable. So I am going to add 2/5 to both sides. Okay? Now, if you are really not the best at fractions, my advice is use Desmos. Like literally, go on here and type negative 1, well, whatever your fraction is, negative 1/4 plus 2/5. Now, the calculator spits out a decimal, and I do not encourage you to use a decimal. I encourage you to use fractions when you're working with fractions. So there's a little button you click here, and voila, it tells you it's 3/20. I mean, that's correct. This would be negative 5/20, and this would be positive 8/20. So negative 5 plus 8 would be 3/20. But if that's something that you're like, I'm not the best at that kind of stuff, I mean, that's fine. You can use the calculator for that. So we get 3/20 equals negative 1/3 u. Now to get rid of this negative 1/3, you have two options. Either A, divide both sides by negative 1/3, which I think is a weird thing to do, or multiply by the reciprocal, negative 3. Negative 3. Yes, when you multiply by negative 3, two things happen. A, the negative times the negative cancels out. And then 1/3 times 3 makes 1 whole. So what happens is on the side over here with the letter, I just have u now. And on this side, well, you multiply these things. Calculator maybe, but it's negative 3 times 3, which is negative 9 over 20. Oh, I'm deleting things left and right. It's so painful. I have to hold it so uncomfortably to do it properly. Why does it have to be this way? Alright, negative 9/20. Yes, a fraction-y one. Check. How long was this? Was this a long video? Yes, 30 minutes long. Well, yeah, sometimes 30 minutes long. What are you going to do? Alright, submit assignment. Go team. Alright, so I'm not going to show you everything here, but I'm just going to run through a quick report. We had a couple of problems that were a little difficult, word problems that you have to set up in a unique way. We had a couple of problems that were very easy to set up. Well, probably easy, I hope. We had a couple of problems that said solve using 2 steps. There was quite a few of those. Let's see, is 9 one of those also? I don't know how far out it is. Oh no, 9 represents the next thing. We had problems where you had to solve it, but it was 2 steps, but one of the steps was that you had a negative in front of the variable, so you got to work that away. Something to look out for. We had some more 2-step problems with positive and negative numbers. There was quite a number of those. We had problems where you either had to distribute or possibly divide before distributing in order to get the answer. We had some problems with fractions that you had to undo, including multiplying before doing anything else because it locks the top in place and makes it movable. And then we had a couple of problems that had decimal and fraction, as the things you have to mess with, right? So if you have to subtract decimals or multiply decimals, fine. If you have to add, subtract, whatever fractions, there you go. All right, I don't want to recap too much more. This is pretty long enough as it is. So if you watched it, thank you. If you watched part of it, thank you. I will do the 2-4 one as soon as I can. Thanks for watching.